Alright, in this video we're going to solve several equations. Now these equations involve exponents in various ways. Some of them, as you can see, we have fractional exponents. Square roots are really fractional exponents as well. Like this is the same thing as 5 minus 7 to the 1/5 power. Alright, that's why they're showing up in this unit. But also we will be solving some equations that have a variable for an exponent. Alright, here I have a variable, it's the 5x power. So that's something different than the first two. So we'll solve some equations like this. Do not distribute. You can't distribute when there is an exponent. And I recommend that you not try to divide first either. Alright, if you try to divide, you would have to divide the 13, and that's ugly. Instead, you should start by adding 13 to both sides, get that out of the way. We're trying to get the parentheses by themselves. So I'm going to add 13 to both sides. That is going to leave me with 4 times 3x minus 10 to the 4/3 power is equal to 64. Now we will divide both sides by 4 to get rid of this 4. So that is going to leave me with 3x minus 10 to the 4/3 power is equal to 16. Now, if you want to get rid of this fractional power, you need to do the reciprocal power. So 4 over 3, I'm going to do 3 over 4 power to both sides. Alright, I'm going to raise each side of the equation to the 3/4 power. Now over here, these are going to wind up canceling each other out. So I'm going to just have 3x minus 10 now. Now over here, I need to simplify this. So power over root. Alright, power over root. So I'm doing the 4th root of 16. Alright, I'll put the little 4 in there. That's the 4th root of 16. And then 3 is the power, so I'm going to do that to the 3rd power. Now the 4th root of 16, we can use the chart if we need to. The 4th root of 16 is 2. Okay. So, I'm just going to do this off to the side. In green, no less. So if I want to do the 4th root of 16 and then raise that to the 3rd power. The 4th root of 16 is 2. And then 2 to the 3rd power is 8. So that means this is going to be 8. So I will have 3x minus 10 is equal to 8. And then we go on and solve it like we always do. So we're going to add 10 to both sides. And that gives us 3x is equal to 18. And then we'll divide both sides by 3. And that gives us x equals 6. Alright, so that is the answer for number 20, is x is equal to 6. So, let's move on, talk about number 21. Alright, do not try to raise each of these to the 5th power right now. You can't just raise the 2 pieces of the same side of an equation to a 5th power. We need these radicals on opposite sides. So I'm going to take this radical and move it over to the right by adding the entire thing to both sides. So very quickly, that's going to give me the 5th root of 5x minus 7 equals the 5th root of 3x plus 11. Get them on opposite sides. Now, I can raise both sides of my equation to the 5th power. Alright, that's all you're allowed to do. You can raise both sides of an equation. You can't raise two parts of one side of an equation to a power. But I can do this, and that's going to cancel out the root. So I'm going to wind up with 5x minus 7 equals 3x plus 11. And then we just solve it like you learned to do in the 8th grade. I have my x's on opposite sides of the equation, so I will get those together by subtracting 3x from both sides. So that's going to give me 2x minus 7 is equal to 11. Then I will add 7 to both sides. I'm just trying to get x by itself. Alright, so that's going to give me 2x is equal to 18. And then I'm going to divide both sides by 2. And that is going to give me x is equal to 9. Okay, so there's number 21. All right, let's take a look at number 22. Okay, we need to get this base and power by itself. So we need to get rid of this 1/2. The easiest way to get rid of this 1/2 would be to multiply both sides by 2. So if I multiply by 2 on the left and the right, that way these 2's will cancel each other out. So now I have 4 to the 6x plus 1 power is equal to, all right, now 2 times 128, that's 256. So here's how you handle it. When you have a variable in the exponent, the easiest thing to do is to try to get like bases. All right. In the next unit, we're going to learn about something called logarithms, which will give us another way to solve these equations that work for, all problems. But for now, we have to stick with problems that can be written using the same base. So here I see I have a base 4. So I'm wondering if I can write 256 as a base 4. So I'm going to look at my exponent table. Okay, here's my base 4, and here's 256. So 4 to the 4th power is 256. Alright, so fine. So I'm going to rewrite 256 as 4 to the 4th power. So over here I have 4 to the 6x plus 1 power, and that's equal to 4 to the 4th power. Alright, that only makes sense if the exponents are equal. So that means I can set the exponents equal to each other and make a new equation. 6x plus 1 must equal 4. Alright, these must equal each other. And then again, we're back to our 8th grade math. So we will subtract 1 from both sides, and that will give us 6x is equal to 3. And do not divide by 3. We're trying to get x by itself, so you have to divide by 6. Even though it's a bigger number, so it makes you feel all weird inside, too bad. Deal with it. So this is going to give us x is equal to 3 over 6 reduces down to 1/2. Okay, so that's it for number 22. Number 23 is very similar. We need to write these as the same base. Now I'm looking at the 8, and okay, if I look at my chart, 8, base 8, I got 64, 512. Alright, the very first number, there's no 32. So what am I going to do? Well, I need to change both of these. That's the bottom line. How can I write 8 and 32 as the same base? Basically, see if you can find 8 and 32 on the same row here. There's 8 and there's 32. That means I could use base 2. Okay, in fact, that's what we have to do. Okay, so if you see that 8 and 32 are both in the 2 row, so we can write 8 as 2 to the 3rd power, and we can write 32 as 2 to the 5th power. They can both become base 2. You got to change. Sometimes you got to change them both. So 8, like we said, is going to be 2 to the 3rd power, and 32 is 2 to the 5th power. So this part that's left over, the 5x, we're just going to put that in parentheses. Alright, so I guess I didn't have to do that over here. Okay, so I'm going to put that in parentheses. And the 2x minus 3, again, I'm going to put that in parentheses. Alright, so now I have the bases the same, 2 and 2. That means these exponents must be equal. In other words, 3 times 5x must equal 5 times 2x minus 3. The exponents must be equal. So this is 15x, which equals, and we must distribute. So that is going to be 10x minus 15. I'm seeing these x's on opposite sides of the equation. I'm going to pull them together by subtracting 10x from both sides. So that's going to give me 5x is equal to negative 15. Then we will divide both sides by 5 to get x by itself. Okay, so that is going to give us x is equal to negative 3. Okay, so that is number 23. Now, number 24. This just has one radical in it, so we're going to start by getting this radical by itself. So your first move should be to subtract 10 from both sides. But then that's going to give us the square root of x plus 6 is equal to negative 5. This is impossible. You can't take the square root of something and then have it equal to a negative number. If I have the square root of question mark is equal to negative 5, there's nothing I could put in here that's going to give me a negative 5. If I put in negative 25, that would be 5i, not negative 5. So this is no solution. Alright, if you kept going by squaring both sides, because that's normally how you get rid of the radical, you would get an answer. But if you substituted that value back in, you will find that it will not make a true statement. It won't work. So feel free to go ahead and try to square both sides. This would make positive 25 after you squared it, blah, blah, blah. Check it out. Plug it back in. Substitute it back in. See what you get. Anyway, let's move on. So again, to solve an equation like this with the parentheses and the power, we need to get this part by itself first. So we will add 5 to both sides. So that will give us x minus 7 to the 3rd power is equal to 216. Now, if I want to uncube this, I can take the cube root of both sides. Alright, so I'm going to do the cube root over here, and I will do the cube root over here. Now these will cancel each other out and just leave me with x minus 7. Now the cube root of 216, is 6. So now I've got 6. And of course now I'm just going to add 7 to both sides. So that gives us x equals 13. All right. And number 26. All right, this will be the last problem in this video. If I want to get rid of this radical, I need to square both sides. But be careful. When I square this side, use parentheses. All right, I will not just square the x and square the 4. You can't just square the pieces. You have to square the entire right-hand side of the equation. So I'm squaring both sides of the equation. On the left side, that does just make the radical go away. So I have x plus 10. Now on the right-hand side, I have to realize that I'm going to have x plus 4 times x plus 4. So you're going to have to double distribute this. So right, x times x, that's x squared. X times 4, that's 4x. 4 times x, that's another 4x. 4 times 4, that's 16. So I've got x plus 10 equals, so that's x squared plus 8x, all right, I'm just combining my like terms, plus 16. All right, now I see that I have x squared and x, so I need to get 0 on one side. Rather than moving all this, I'm just going to move these two. So I am going to subtract x from both sides, all right, that goes here with the 8x, and I'm going to subtract 10 from both sides. That's going to go right here. So now I have 0 on one side. So I've got x squared plus 7x, okay, plus 6. Now, hopefully this is factorable. If not, I will have to use the quadratic formula. So let's try to factor it though. So binomial times a binomial. So x squared, that's going to be x times x. 6, it's either going to be 2 times 3 or 6 times 1. Seeing the 7, I'm definitely going to try 6 times 1 first. Now, inner plus outer equals middle. Inner, I have 1x. Outer, I have 6x. If I just let them both be positive, that'll make 7x. And 1 times 6 is 6. So there we factored it. Then you set these pieces equal to 0 and solve. So I think I'll just do that over here. So, so if I have x plus 1 equals 0, and if I have x plus 6 equals 0, that's going to give me x equals -1 and x equals -6. Okay, now be careful. Anytime I get two solutions, I always check them. In fact, you know what, let me leave space. So over here, this is going to give me x equals -1, and x equals -6. I'm going to use this space over here to check the answers. Very often when you have two solutions, one of them doesn't actually work. Alright, you should always check a square root problem to be sure. So if I put in -1, then, alright, so this is my check. Okay, this is my check of x equals -1. If I put in -1, then that's -1 plus 10, and that's supposed to equal -1 plus 4. Well, -1 plus 10, so that's the square root of 9, and this is 3. And the square root of 9 is 3, so that checks out okay. Okay, so now I'm going to check x equals -6. Okay, so x equals -1, that worked. So I can go ahead and put a box around that. Alright, so now I'm checking -6. So that would be the square root of -6 plus 10. Okay, -6 plus 10. Guess I should be looking over here. And then it'll be negative 6 plus 4 on the other side. Alright, so this will make the square root of negative 6 plus 10 is 4. Negative 6 plus 4 is negative 2. But the square root of 4 is positive 2. Positive 2 does not equal negative 2. So that means negative 6 does not actually work. That is what we call extraneous. Alright, so do not put a box around it. X equals negative 1 is the only answer to this particular problem. Alright, that's going to do it for this video.